So in this video, we're going to be looking at two specific examples that are related to solving an exponential function. So the first example is going to deal with half-life, which half-life is exponential decay. So in chemistry, you see half-life with isotopes, and what half-life means is if you start with a certain amount of the isotope, it's going to decay, and exactly half of it will be left at its specified time. So for example, if I say the half-life of something is 10 minutes, that means after 10 minutes, half of the population will be left. So here's our first example. The half-life of gold 195M is approximately 30.5 seconds. So what that means, just to interpret those results, means that after 30.5 seconds, half of the isotope is gone. So if you start with 10 grams, after 30.5 seconds, you're down to 5. If you start with 20 grams, after 30.5 seconds, you're down to 10. So the half-life of gold 195M is approximately 30.5 seconds. Now, part 1 asks me to determine a value such that this thing is true, and I want to round to 6 decimals. So such that this equation is true. So the first thing I'm going to do is just simply write down that equation they give me. Now that A0 is your starting amount. A of t, the one on the left, that's your amount at some time. So this is the amount at time 0, at the starting amount, and this is the amount after 10 seconds, 20 seconds, 40 seconds, whatever it may be. I am looking for this value right here, this A. So what this half-life means is that the amount of gold left after 30.5 seconds, because that is its actual half-life, the amount of gold left after that is going to be half of the original stuff, of the original amount. So again, what this says is after 30.5 seconds, the amount that's left is going to be half of the starting amount. And I got this 30.5 from the half-life being defined by that number. So again, the amount at 30.5 is half of the starting amount. So now what I need to do with this part right here on the left, I need to write that in the function. So what this means is where there was a t, replace with a 30.5. So I'll have A0, A, and then raised to the t power, but t in this case is 30.5. And then I carry down that right-hand side, 1/2 A0. So now I have this nice function that I'm able to actually solve for A. So again, I'm working on getting this A by itself, so I'm going to go ahead and highlight that. I'm trying to get that A by itself. So to get rid of the A0 in front, I'm going to divide by A0, divide by A0, and it ends up crossing out on both sides, so I'll be left with A 30.5 equals 1/2. So I'm trying to get A by itself. So if I want to get rid of an exponent, I can multiply the exponent in the or I can multiply the reciprocal of the exponent. So the reciprocal of 30.5 is going to be 1 over 30.5. And if I do that on the left, I have to do that on the right. So the reason I can do that, if you remember my power to a power rule, you have two exponents, a power to a power, you will multiply those two. So 30.5 times 1 over 30.5, the 30.5s are going to cancel and actually will leave you with just A over there. On the right-hand side, you're going to type that thing in your calculator. You'll get out 0.97753. It says round to 6 decimal places, so that will be your A value for step 1. So step 2 says how much of a 12-gram sample would remain after 41 seconds of this gold that I left out. So round to 3 decimals. So I found that A in step 1. So what I'm going to do is plug all of that into my equation. So there's my new equation with the A filled in. Now I'm going to go back and hopefully fill in some of these other unknowns. So if you remember the A of T, that's your ending amount, and the A sub 0, that's the starting amount. So how much of 12-gram sample would remain after 41 seconds? So 12 gram is my starting amount. That is my initial amount of gold. So I'm going to plug in 12 grams, still have that same A. And then my time, T, it says how much of 12 grams would remain after 41 seconds. So that's going to be my time. So now pause the video, plug this all in your calculator, type it in, get 4.726 grams. So after 41 seconds, you'll have a little bit more than 4 grams of gold left over. So here's my second example, changing gears away from the isotope. So a certain species of deer is introduced into the forest, modeling this, P of T equals 493, 4 to the T over K, or T over 2, where T is years from the time of introduction. So they gave me the formula. That's this thing right here. They gave me that. And then step 1 says, what is the quadrupling time for this population? So you'll see on the screen, I went ahead and reminded you that the 493, that's the starting amount of deer. That is always your A sub 0, your starting amount, your starting population, your starting amount of isotope like in the last example. But in this case, it's 493 deer were the starting amount. So step 1 says, what is the quadrupling time? Well, quadrupling means that you're going to multiply by 4. Quadrupling is 4 times whatever. So I'm going to take 493 and multiply by 4, and that's going to get me the amount of deer I want to find that time for. Because again, it says, what is the quadrupling time? So I want to know how long until the deer quadruple, meaning until I have 493 times 4, which gives me out 1972. That's what's going to go in my ending amount, so my population. Now I'm able to solve for T. So I'm going to divide both sides by this 493, get rid of that. 1972 divided by 493 is going to give me 4. And then I have that thing. Those cancel. So if I don't see an exponent, I can write it as a 1. So this is actually 4 to the 1 power equals 4 to the T over 2. So those 4's will cancel. We use that term loosely from 5.1. And then I have 1 equals T over 2. So multiply both sides by 2. So after 2 years, the deer population will have quadrupled. So here's the second part to that example. How long, that's a time, how long until the population will reach 7,888 deer according to this model? So there's my population, P of T. So I want to know how long, how many years, T, how long until the population reaches this number. So that's my ending amount. That's what I'm hoping to find a time for. So I'm going to have that equals 493, 4 to the T over 2. So I'm still working on finding T. So I'm going to divide both sides by 493. Get 16 equals 4 T over 2. So I need to make these bases the same. I'm going to rewrite 16 as 4 squared. So now that I have like bases, can kind of cancel them out. And I'll have 2 equals t over 2 multiplied by 2 and get t equals 4. So after 4 years, the population will be at 7,888.